Okay guys, so we are moving on to more circles. Today we're going to learn about tangents, and a tangent is a line that intersects a circle in exactly one point. This point is called the point of tangency. So really, a tangent is a line that touches the circle at exactly one point. So if you look at the line that I've just drawn, this line is touching the circle right there. No matter what, if I extend this line left, right, forever, will I ever touch the circle again? No, we're not, because it's not, because no matter what, it's extending left, right, but it won't cut through the circle again. Right, examples of things that are not tangents. So if I have, let's undo that one. Let's say I have something like this. This is not a tangent. This is definitely not a tangent because a tangent is a line. A line extends infinitely far in both directions. So even though right now the way it's drawn, it shows that it's only touching the circle there, if I extend this line in the other direction, won't I end up touching the circle again? Absolutely. So that is absolutely not a tangent. Not a tangent. Okay, another example of what's not a tangent, obviously something like this is not a tangent because we are touching in two points, so these are not tangents. Okay, let's talk about a tangent segment. A tangent segment is the part of the tangent line that's between the point of contact and the point outside of the circle. So for example, a tangent segment is something that looks like this. Now, a tangent segment is part of a tangent line. So if I were to extend this line, I have to make sure that it's again not going to touch the circle again, other than at that one point. So if I extend this line in this segment in the other direction, it still will not touch the circle more than once. So what is not an example of a tangent segment? What I'm drawing now, is not a tangent segment. Okay, something like this. This is not a tangent. Oops, sorry, let's put a endpoint there. This is not a tangent segment. Why is this not a tangent segment? Because remember, every segment is part of a line. If I were to take this segment and extend it, wouldn't I end up touching the circle again? So even for tangent segments, you have to envision that if you extend that segment into a line, it still isn't allowed to touch the circle again. A tangent line / segment is perpendicular to the radius drawn at the point of contact. What does that mean? That means if I have a tangent line or I have a tangent segment, and I draw a radius to that tangent line or tangent segment, where the radius and the tangent line meet has to always make right angles. Where the radius and the tangent line meet will always make right angles. All right, let's turn the page. Let's do some problems. All right, so we know AB is tangent to the circle. So AB is tangent. So even if it doesn't look tangent and I tell you it's tangent, you just believe in the given information. So AB is tangent. AC is 17 units long. And AB is 15 units long. We want to find the radius. Well, we know E to C is a radius, but that's not really going to help me because we don't know that these are split in half. So I can't say, oh, it's 8.5 because there's nothing telling us that it's split in half. So what am I going to do? Well, I'm going to draw another radius. I'm going to draw a radius from C to the point of tangency at B. And if you guys remember, where our radius touches a tangent is a right angle. And I'm sorry, I mislabeled AB. We were told AB is 15 units long, not 13. So remember, a radius where it touches a tangent has to make right angles. So now we have a right triangle, but not only do we have a right triangle, we have a very special right triangle. It is a triple, an 8, 15, 17. So the radius is 8. And remember, a diameter is 2 times a radius. A diameter is double the radius. So we're going to say 2 times 8, which is 16. And now we know EC is also a radius, which means all radii are congruent, so that has to be 8. So AE is going to be 17 minus 8, which is 9. Okay, next problem. It's telling us we're going to draw in our own diagram. AB is tangent to circle O at A. So this obviously is circle O. It's on top. And we're going to draw segment AB that's going to be tangent at point A. So I'm going to call that point A. And AB, segment AB, so there's our segment, right, starting at A, ending at B. We're being told that AB is 48 units long, and O to B is 50 units long, and we want to find a radius. So I'm going to draw in a radius from O to A, and remember, when a radius is drawn to a tangent, it has to make right angles. Now, I don't know about you, but I definitely do not want to do the Pythagorean theorem on 50 and 48. So what am I going to do? I'm going to reduce this triangle, so I'm going to divide by 2. And when I divide by 2, I get a 24 and a 25, and this is in fact a triple. 7, 24, 25. Go back, multiply by 2, and we get a 14. So the radius of the circle is 14. The diameter is going to be 2 times 14, which is 28. Okay, you can go ahead, pause the video right now, do the independent. Once you're done, you can go through to see how it is done. So it says TP is tangent to the circle at O at T, so I'm going to create segment TP. So we're tangent at T, so it's going from T to P, and there's our circle O. They're telling us that TP is 6 units long, and the radius is 8, so I'm going to draw a radius from O to T, which also makes a right angle. That's 8. And now we want to find the length of O to P. Well, I don't know if you realize this, but if you divide by 2, we get a little smaller triangle. We get a 4 and a 3, which is a 3, 4, 5. Go back, multiply by 2, we get OP is 10 units long. All right, let's keep going. We have AC and BC are tangents to circle D. AC is 30, and the radius is 16. So what am I going to do? Well, I'm going to actually draw in 2 radii. I'm going to draw a radius from D to A. And what does that make? That makes a right angle. I'm going to draw in another radius from D to B. What does that do? That makes a right angle. We know these are both 16 units long. And we want to find the length of CD. So I have to actually draw in CD. So if I notice, what do I notice? I actually have 2 triangles. And these triangles actually end up being congruent. They end up being congruent by hypotenuse leg. So what does that mean? If AC is 30, BC is also 30. And now we want to find CD. Well, CD, I definitely do not want to do the Pythagorean theorem on 16 and 30. So what am I going to do? I'm going to divide by 2. I'm going to create a new smaller triangle. And I'm going to have an 8 and a 15, which is a triple. 8, 15, 17. Don't forget to multiply. We divided by 2. Don't forget to multiply back by 2. So we're going to get 34. And the length of BC is 30. What do we notice about the tangent segments? They are congruent. And that is definitely not a coincidence. So let's turn the page. We have a theorem. If two tangent segments are drawn to a circle from an external point, those two segments are congruent. What does that mean? It means if I have from a single point, the same point, two segments that are tangent to the same circle, so here xy and px and py are both tangent from point P, these two segments will always end up being congruent. So px is congruent to py. So if you have two tangents coming from the same outside point, those two tangents have to be congruent. All right, let's do some problems. So I have circle C. AB and AD are tangents, and notice they're tangents both coming from A. What do we know? That means those two tangents have to be congruent. So 3x plus 10 has to equal 7x minus 6. We're going to subtract 3x on both sides. So we're going to have 10 is equal to 4x minus 6. Add 6 on both sides. 4x is equal to 16, so x will equal 4. We want to find the length of AB. Well, AB is not 4. AB is going to be 3 times 4 plus 10, which is going to be 22 units long. Okay, new definition. Concentric, not new definitions, recall. We've learned this definition before. Concentric circles are two or more coplanar circles with the same center. So it's two circles with the same center. All right, so here we have concentric circles with radii 5 and 8. BC is tangent to the inner circle at D. All right, so I'm going to obviously draw in my radii. The first radius I'm going to draw is going to be from A to D. Obviously, that's going to be my smaller radius. So the smaller circle will have a radius of 5. And what happens when a radius touches a tangent? We're going to get right angles. And then they're saying the bigger radius is 8. My whole goal here is to make right triangles. So I can draw 8 a whole bunch of places. I could draw 8 there, but that's not going to help me. Where can I draw the radius of 8 that will actually help? I'm going to draw it from A to B so I can complete my right triangle. Now, when a radius is perpendicular, remember, it also bisects. We learned that a couple lessons ago. When a radius is perpendicular, it also bisects the chord. So now I know, let's call this x. We know this also has to be x. I need to solve for x. How am I going to solve for x? Well, we have the right triangle, but unfortunately, this is not a triple. So we actually have to do the Pythagorean theorem. So let's set that up. We're going to have x squared plus 5 squared equals 8 squared. So we have x squared plus 25 is equal to 64. We're going to have x squared is equal to 39, square root both sides. We cannot break down the root of 39, and this is not our answer. This is root 39, which means this is root 39, so all of b to c is 2 root 39. All right, let's turn the page. All right, so once again, we have concentric circles with point A as the center. The smaller circle has a radius of 21. BD is the tangent to the inner circle at C, and B to D is 56. So if B to D is 56, let's remember when a radius is perpendicular, which it is, to a chord, it also bisects the chord, so that 56 is going to get split into 28 and 28. Now they're telling us the radius of the smaller circle is 21, so that means segment A to C is 21. We want to find the radius of the larger circle. Remember, we're going to draw in the radius so we can make right triangles. So I'm going to draw my radius A to D right there. Now, if you look at the triangle, I'll highlight it in yellow. I definitely do not want to do the Pythagorean theorem on 21 and 28. So what am I going to do? I'm going to divide by 7, and I'm going to create a new smaller triangle. So we're going to have 3 and 4. This is a 3, 4, 5. Don't forget to multiply back by 7. So this will be 35. Find the radius of the larger triangle. It is 35. Now we want to find C to E. Now this one's really sneaky right here. Well, look at A to E. Isn't A to E a radius of the larger circle? So we know AE is a radius which is 35 of the larger circle. So CE is going to be 35 minus 21, which is going to be 14 units long. All right. The last thing we're going to talk about today are common tangents. A common tangent is a line tangent to two circles. So if you notice, we have segment AB as tangent to two different circles in both diagrams. That's considered a common tangent. So let's keep going. We're going to have problems that involve common tangents, and these are the steps. If you memorize these steps, the problems will be so easy for you. If you do not memorize these steps, it's going to be very difficult for you to complete. So what are the steps? Draw the segments joining the centers. Draw the radii to the points of contact, label all given information. Now here's what's so important. Through the center of the smaller circle, draw a line parallel to the common tangent. This line will intersect the radius of the larger circle to form a rectangle and a right triangle. Use a triple or Pythagorean theorem to solve. All right, I'm going to go through these steps again as we actually go through the problem. So let's go ahead and label our problem. We have segment A to B is 25 units long. So from A to B is 25 units long. So I'm going to mark it just like that. A to D is 10 and B to C is 17. So we drew a segment joining the centers. Now we want to draw the radii to the points of contact. What does that mean? That means from the center of the circle, we're going to draw a line to the common tangent. Now remember, when a radius touches a tangent, we always make right angles. So I'm going to draw another segment from the center of circle B, and I'm going to draw it to the point of contact, point C. So that's also going to make a right angle. Now here's what's so important. It says through the center of the smaller circle. Now, which circle is smaller, circle A or circle B? Circle A is smaller. So they're saying go to the center. So I'm going to go center A. I'm going to draw a line. Let's get a different color here. And we're going to draw a line parallel to the common tangent. So I'm going to draw a line from A parallel to DC. And now I hope that you realize that we have a quadrilateral and a triangle. Here's our quadrilateral. And here is our triangle. Now the quadrilateral is in fact a rectangle, and the triangle is a right triangle. Now there's some information I haven't labeled yet. So we were told that A to D is 10 units long, and that B to C is 17. Now remember, the yellow quadrilateral, that's a rectangle. In a rectangle, are and opposite sides congruent? So that means this side is 10, which means the bottom base of this triangle is 7. Now we know A to B is 25. So if you're looking at that blue triangle that I have right here, I have a 7 something 25. What is it? 7, 24, 25. So this altitude is 24. But remember, in a rectangle, opposite sides are congruent, which means DC is also 24. So the common external tangent is 24 units long. Now I know this is really different. We're going to do a couple more problems, same process over and over again. Okay, so now we have, given the radius of circle P is 8, the radius of circle O is 18. Find the common external tangent. So I ultimately want to find the length of A to B. That's what we want to find. So we're going to follow our instructions. We're going to draw a line connecting the centers of the two circles. Now, I know we don't have a length given to us, but we could figure out the length because it says radius of circle P is 8. So from from P to the rim is 8. And then the radius of circle O is 18. So from O to the rim is 18, which means O to P has to be 26. Now we need to draw more radii. We want to draw the radii to the common tangent. So I'm going to draw radius from O to A. And we know that makes a right angle. And P to B, and that makes a right angle. All right, now it's saying from the center of the smaller circle, draw a line parallel to the common tangent. So my smaller circle is P to a line. So from P, I'm going to draw a line parallel. Oh, I want a segment. I'm going to draw a segment parallel to AB. So here we go. So now the rectangle's going that way, which is fine. And remember, there was some information that we didn't label. It says the radius of circle P is 8, so that's 8. The radius of circle O is 18, which means this is 18. Once again, we have a rectangle and a right triangle, so let me highlight this right triangle for you. Okay, now on the top we have a rectangle. We know in a rectangle opposite sides are congruent, so if B to P is 8, then this side is 8, which means this bottom part is 10. Now I'm going to look at that triangle. I have a 10 and a 26. I'm going to divide by 2. So I have, oh, I wrote 24. That's a 26. Silly. Miss A. All right. We're going to divide by 2, so we'll have a 5 and a 13. This is, in fact, a triple. 5, 12, 13. Want to go back and multiply by 2, which means this side is 24. And remember, in a rectangle, opposite sides are congruent, so A to B is also 24. All right, we will do one more problem, and then we will call it a day. All right, so we are told that the segment O to P is 9 units long, so O to P is 9 units long. Right. The radius of circle O is 7, radius of circle P is 5, so I'm going to draw points, radii to the point of contact. And remember, when a radius touches a tangent, we get right angles. We know circle P has a radius of 5, circle O has a radius of 7. Next step is from the center of the smaller circle. So we're going to go from circle P, because that's the smaller circle. I'm going to draw a line parallel to the common tangent. So here we go. What are we going to end up with? We're going to end up with a rectangle and a right triangle. In a rectangle, opposite sides are congruent. So if that's 5, then that's 5. And this will be 2. Unfortunately, we have a right triangle, but it is not a triple. So frustrating when it's not a triple. And we can't even reduce this. So we're going to go ahead and do the Pythagorean theorem. 2 squared plus x squared equals 9 squared. 4 plus x squared equals 81. X squared will equal 77. Square root both sides. X will equal the root of 77. There's no pairs in 77, so we're going to stop right there. This is root 77, which means AB is root 77. So the common external tangent is 77. All right, guys, I know I have filled your brain with information. That was our last problem for today. No homework assigned today. We will do the homework for the next class. So just soak it all up and we will talk again tomorrow. Have a great day. Bye-bye.